So, today we're going to talk about something that is genuinely radical in the world of AI hardware. It's the AMD Instinct MI300X. And look, this isn't just another faster chip. It's a totally different way of thinking about how you build a ridiculous amount of power for this new AI era. And honestly, it looks a lot like a skyscraper made of silicon.
So, that brings us to the central question, right? How do you even build a chip that is fundamentally more powerful than what a single giant piece of silicon can physically be? I mean, there are limits. This is the core engineering puzzle that AMD has been trying to solve, and their answer is what makes this MI300X so fascinating.
And to really get why they had to get so creative, you have to understand the insane scale we're talking about. Modern AI models, they can have hundreds of billions of parameters. AMD basically designed this platform to swallow models of up to 680 billion parameters whole. That requires a mind-boggling amount of computational power. The hard truth is that this whole AI explosion is slamming headfirst into a physical wall. You've probably heard of Moore's Law, the idea that chips get twice as powerful every couple of years. Well, that's slowing down. We just can't keep making single monolithic chips bigger and bigger forever. And yet, the hunger for more AI compute, it seems like it's literally infinite. So what's the answer? If you can't build out, you have to build up. And this brings us to AMD's big idea, this huge strategic bet they made years and years ago, chiplets. And this wasn't some sudden pivot, it's the grand finale of a long-term vision they've been working on for a while. So what in the world are chiplets? It's actually a beautifully simple concept. Instead of trying to make one single, gigantic, perfect, and incredibly expensive piece of silicon, you build your processor out of smaller, specialized, Lego-like building blocks. You can mix and match these little chiplets to create exactly the kind of processor you need. It's brilliant.
And the MI300X didn't just appear out of thin air. It's really the destination of a long journey. It all started back in 2019 with 2D chiplets on their Ryzen CPUs, where different little dies just sat next to each other. Then, in 2021, they took the first leap upwards with 3D V-cache, literally stacking memory on top of the processor. And now, in 2023, we have this, a full-blown skyscraper architecture.
But okay, if you're stacking these layers, how do you actually connect them? Well, the secret sauce is a technology called hybrid bonding. It's this wild technique that basically fuses the chip layers directly together, copper to copper. This gets rid of the tiny little solder balls or micro bumps that everybody else uses.
And the difference here is just staggering. I mean, the traditional way works, but it's way less dense and it's a power hog. Hybrid bonding gives you over 15 times the connection density while using only a third of the energy. That efficiency, that's what makes this whole silicon skyscraper idea even possible. It's a total game changer.
All right, now that we've got the theory down, let's actually take a tour of the skyscraper itself. Let's peel back the layers and take a look at the anatomy of this absolute beast, the MI300X.
And the scale we're talking about is just immense. The final finished chip is made of 153 billion transistors. It's a colossal piece of engineering, and it's only possible because they're assembling it from all those smaller, more manageable chiplet blocks.
So here's the blueprint. It all starts with the foundation, which is made of these I/O dies. Then, on top of that, AMD stacks the compute towers. That's where all the heavy lifting happens. And then surrounding the whole thing are the memory stacks, which act like these massive fuel tanks, just feeding the chip with over 5 terabytes of data every single second.
Okay, that architecture is incredible, right? But what's the payoff? Let's switch gears from how it's built to what it actually does when you put it to work on real demanding AI tasks.
So what does this wild skyscraper design actually get you? What does it do better than a more traditional chip? Well, the answer really boils down to one massive advantage that this whole architecture makes possible: memory, and a lot of it. Just look at this comparison. A standard, super high-end NVIDIA H100 platform can run a model with about 290 billion parameters. That's huge. But the AMD MI300X platform, with its 1.5 terabytes of HBM3 memory, it can handle a model of around 680 billion parameters. It's not just a little better, it is in a completely different league.
And this raw advantage, it shows up big time in performance benchmarks. This chart is based on data from the tech reviewers at Chips and Cheese, and it shows performance on the popular Llama 3 model. Now what's just incredible here is that a single MI300X is outperforming 2 of NVIDIA's top-tier H100 GPUs working together.
And really, that's the bottom line. That's the whole story. A single MI300X can fit and run massive AI models that its competitors simply cannot handle on one chip. And that lets you avoid the super slow process of splitting models across a bunch of different GPUs, which gives it this massive fundamental advantage.
So the hardware story is just incredibly compelling. It's amazing. But building the world's most powerful AI chip is only half the battle. Now we have to talk about the final boss, the software challenge. The experts over at Chips and Cheese put it perfectly. The software side has this classic chicken and egg problem, right? Developers don't want to waste time supporting a platform until it's super popular, but the platform can't get popular unless developers support it. It's a tough spot. And this right here is the battlefield. On one side, you have NVIDIA's CUDA. It's the king. It's the dominant software platform that's been built and optimized for decades. It's the industry standard. And on the other side, you've got AMD's open-source challenger, ROCm. It's growing, it's getting better, but it just doesn't have the same maturity or the same universal support. This is AMD's mountain to climb.
But AMD knows this. They are not ignoring this problem. At a recent conference, their CEO, Dr. Lisa Su, she made their strategy crystal clear. They want ROCm to be everywhere, not just on these huge data center GPUs, but on their consumer gaming cards and even their smaller APUs. The thinking is, if they can make it ubiquitous, they can finally break that chicken and egg cycle.
Which leaves us with the big, multi-billion-dollar question. AMD has built a truly revolutionary piece of hardware, a silicon skyscraper that completely changes the game. But is that raw power, that incredible engineering, is it enough to finally break through NVIDIA's formidable software fortress? That right there is the battle we're all going to be watching.